Hey Brenna, so my apologies for yesterday. You absolutely stumped me with the way you were doing it. It was different than the way the kids typically do it in class. So anyway, I figured it out on my way home of what we were doing wrong, and so I'm going to try to make this as quick as I can, but I also want to take our time in my explanations and make sure that it's clear. So we know that each minute covers 6 degrees. And the hour hand, this is kind of what we were missing yesterday, covers 1/2 x, where x is the number of minutes that have passed in the hour so far. So where that comes from is that your x is the number of minutes that have passed so far out of the 60 that are available in the hour. We'd multiply that by 5 to figure out what portion of the 5 increments of a clock there are. So in that hour, say between 5 and 6 o'clock, there's 5 increments, just like there's 5 minutes. And then you multiply it by the 6 degrees that each one of those increments are worth. And that, when you clean it up, you end up getting 30x over 60, which then simplifies to that 1/2 x. So that's why in the work that we've been doing, we multiply the minutes by the 1/2, because it's really to take into account the amount of degrees that have been moved because of the hour. So now yesterday, with our example, our hour hand is not exactly on the hour and our minutes hands were not exactly on the minutes. And so for a question like this, that's why we were having the issues, because we were not taking this portion and this portion into account. We were only taking one. So now what that means is that the space that's in between here and here, that's going to be that 1/2 x that we're talking about. And because it's less than the angle, we're actually going to be taking it away. So it's a negative 1/2 x. What we were forgetting to kind of incorporate in yesterday is that the portion of the minutes has to involve a 6. So in this case, since we're taking away 1 minute, we're actually taking away 6 degrees. So now using the method from yesterday that you liked with the 30, if I go from 1 to say 5 o'clock, I'm talking about 1, 2, 3, 4. So we've got 4 times your 30 degrees, which gives us that 120. And now if we take away these two places, we'll get the correct answer. So we get that 120 degrees, we subtract, in this case, the number of minutes that have passed in the hour are 24, and the number of minutes that are in between where our minute hand is and this 5 is 1 minute, so we'd only have to take away 6 degrees. And cleaning this up, we get 120 minus 12 minus 6, which results in that 102 degrees, which is the correct answer for the angle. Okay, so now we're going to take a couple steps back and make it a little bit less work intense, and take a look at some of the ones that have the hour that's in between, but the minute hand exactly on. So when we draw the line to the hour, we don't have to do anything with the minutes because it's already there. And we look at the number of increments that are between 4 and 8. We've got 1, 2, 3, 4. So we've got that 4 times the 30. So we start with the 120. And now because that 4 is outside of our angle here, we're going to be subtracting that portion of that 1/2 x. So we have our 120 minus the 1/2 x, which in this case, the number of minutes that have gone by in the hour are 40, which ends up giving us that 100 degrees, which is what the angle is in measurement. Now our other option here is if you were to draw this hour hand to the 5 instead. So then, instead of subtracting that 1/2 x, we're gonna have to add it. But because we're rounding to the hour ahead, it changes our formula to not the minutes that are past in the hour, but the minutes that are remaining in the hour. So when we look at the increments, we've got 1, 2, 3 increments this time. So we start with our 3 times 30. And again, we're going to be adding on, not the minutes that are left in the hour, not the minutes that have passed in the hour, but the minutes that we have left in it. So we've got 90 plus that 10, which gives us that 100. So this method lets you do either, but time and time again, drawing it to the hour is going to be the more straightforward, easier method to use. All right, so now for our 820, I'm going to only do this one to the hour, just because why not just do it doing it the second way. So now I've got 8 o'clock. I'm going to draw it to the hour. The 20 I don't have to do anything with. Hold on 1 second. I'm going to pause this because I've got a crying baby and I might have to send you a second video with the rest of this. Okay, so attempt number 2. So we had left off by drawing that dotted line to the hour. From here, I want to take a look at that portion that's in between our hour hand and the dotted line that we just looked at. Because that portion is going to be outside of our angle, we're going to be adding on that extra piece right there. So we start with counting the number of increments like we always do, and we get that 120 to start with. Now we take a look at the number of hours that have passed, which is 20, and again, since it's outside of that line, we're going to be adding that 10 on. So we end up getting 130 degrees. Okay, so sticking with this drawing to the hour, let's just summarize the easiest method. So if you always draw to the hour, then for the hour hand, if the hour hand is outside the angle, you're going to be adding that 1/2 x on. If the hour hand is inside of the angle, you're going to be taking it away, which makes sense because it's either getting bigger or smaller depending on what the angle looks like. Now for the minute hand, this is the part that we are only going to do if the minute hand is not exactly on an hour. Which in the last 2 examples, the 820 and the 440, we didn't have to do, but we did have to do in our original example, and we will do one more time after this. So for each minute outside of the angle, you're gonna add 6 degrees because each minute represents 6 degrees on the clock. And for each minute that's within the angle, you're going to subtract the 6 degrees. Okay, so for our very last example, we're going to take a look at it. We're going to do it 2 different ways, depending on what you would like to do with that minute hand. I've drawn it to the hour for both though. So we have 7:43, my black lines are the actual clock, the purple lines are my dotted lines. And so I'm going to start with counting the increments from my purple line to purple line. It is 1 increment, so I'm going to start with the 30 degrees. Now, because my hour hand here, I've drawn this, is outside of my angle, my hour hand is outside, that I drew, is going to be outside. I'm going to be, all right, here we go, finishing this off. Sorry about that. He started getting fussy and I lost my train of thought. So when we draw the dotted line to the hour, and then we draw it to the close to the 8 in this case. If I'm looking at the hour itself, because this dotted line hour hand here is outside is inside of our angle, we're going to be taking away that 1/2 times the 43 minutes that have passed in the hour. And now we look at the number of minutes that are between my angle and out here. So when I look at that, I say, okay, from 40 to 43, 3 minutes have passed. So I'm going to have to be adding the 6 degrees for each one of those minutes onto this equation. So 3 times the 6 is going to give me that 18. Half of 43 is 21.5. Plus my 18 gives me an angle of the 26.5 degrees. Now, I prefer doing it the second way, which is actually drawing the lines outside of both of them so that you're consistently taking away on both sides. So I'll be taking away on this side and taking away on this side to get what my actual angle is. So now when I look at the increments here, from 7 to 9, I've got 2 increments, so 2 times my 30 gives me an angle of 60 to start with. Now I'm going to take a look at the hour hand first. I've got to take away the 1/2 of the 43 minutes that have passed. And now when I look at the minutes, when I look at how many minutes are between the 9 and the 43, 2 minutes are in between them. So I've got 2 times 6, which I'm also taking away, and I end up getting the exact same result of 26.5. So it's up to you whether you want to do it where you're kind of taking a look at each and say, am I adding on and subtracting this? Or if you want to draw it outside and just keep it consistent. But the main thing to remember is that when you're dealing with the hour, it's 1/2 times the number of minutes that have passed. And when you're dealing with the minutes, it's the number of minutes times 6 degrees. All right, I will see you tomorrow. Thanks for being patient.